Hg, and F2. So again, I'm going to crisscross backwards. Okay? Crisscross this way, crisscross this way. Alrighty. Mercury is a transition metal. Fluorine has a +2, I'm sorry. Yes, forgive me, -1 charge. See this 1 over here? Crisscross backwards. This 2 crisscross backwards is a +2 charge. So in this case, it's going to be mercury, parentheses, 1, 2, close parentheses, fluor, and again, I had a misspell. There's a U. I always forget that U. Fluor, and then ide, IDE as the suffix. Not bad. Let's keep going. Copper, Cu, and oxygen. Well, let's crisscross backwards. So I'm going to crisscross this way, crisscross this way. Do not get me wrong. I agree if you're seeing a number 1 because those are invisible. But I know because on the periodic table, oxygen is in group 16, which causes it to have a -2 charge. And I know that this is an ionic compound that has a transition metal in it, and ionic compounds are reduced. So this is a -2 charge, this is a +2 charge, and they got reduced to a 1 and a 1. So now this is going to be copper, parentheses 2, oxide. Alrighty, not bad. Let's go ahead and let's do this one. Let's name the formula over here. Iron is a +3 charge. Remember, all metals are a positive charge. Oxygen is going to be a -2 charge in group 16. Now we're going to crisscross these down like we traditionally do. And let's write the actual formula, which would be Fe for iron, okay, 2, O for oxygen, and this 3 comes down. Let's do it again. Copper, Roman numeral 2 in the parentheses, so that's going to be a +2. Chlorine, go to the periodic table and you can find chlorine in group 17. Group 17 means that it's a -1 charge. Crisscross down like we traditionally would. And let's go ahead and write the formula. Cu for copper. What came down? The number 1, so we don't put a 1, it's invisible. Chlorine is Cl, and this 2 came down, okay? So hopefully it's not too hard. I think this is going to be pretty easy once you practice it a few times. But let's go ahead and get to the next topic of naming, which contains polyatomic ions now. Remember, polyatomic ions, it has that word in it, ions. And ions are part of ionic compounds, okay? So polyatomic ions are included into the ionic compound naming and formulas. All right, don't forget it. Again, though, you do not have to memorize all those polyatomics. Remember, in our formula chart, it's already there. But are those the only polyatomics? No, there's more polyatomics out there. That's just the most common on your formula chart. Let's read the rules. Follow the same general rules from the monatomic that we talked about over on the previous page for ionic compounds. Okay, not a problem. Let's go back before we go any further. What were those rules? The first name is going to be named out completely, okay? And then the second name is going to have the root word and then "ide" as a suffix. If the compound contains polyatomic ion, simply name the ion. Okay, not bad. Pretty easy, right? NaOH. OH is a polyatomic. Okay, they come together. So Na stands for sodium, OH is hydroxide, so the name is sodium hydroxide. That's it. We're going to have Na, which is sodium, OH, hydroxide. That is the name of the polyatomic. You can find it in your notes, or if you printed out the formula chart, it's over there too. Let's look at another example. Cu, which is copper, and then NO3, okay, which is going to be nitrate. So copper for the naming. Don't forget though, this too, when I crisscrossed it backwards, meant that copper is a +2 charge. This nitrate is a -1 charge. So copper, Roman numeral 2 in parentheses, nitrate. So don't forget that crisscrossing backwards. Name the following ionic compound. So let's just practice this, okay? So I'm going to come over here and I'm going to say Na, and then there goes our polyatomic. CO and our polyatomic. Calcium, our polyatomic. Radium, and then our polyatomic, okay? Just to hopefully that will help us out. The other thing is when I'm doing my polyatomics, let's go ahead and let's practice, or let's write out, or we can work our stuff backwards if needed. But sodium is a regular metal. It's not a transition metal, so we don't need to do anything with that one. Okay, we don't have to worry and stress about that one. But don't forget though, we're naming right now, so we don't need to worry about parentheses because it's not a transition metal. It's a regular metal. So what do I do with the first name? I write the first name out completely as is. So sodium. Remember, there's no prefix, so that's pretty easy. And then we go to C2H3O2 to your polyatomic chart and find that polyatomic ion. And you're going to name it as is. You do not have to change anything, which is acetate. Done. Let's practice over here. Calcium. Calcium is a metal, and it's a regular metal, not a transition. So we're going to write the name as is, calcium. And then ClO, okay? Well, let's go to the periodic table. I'm sorry. Let's go to your notes or to your formula chart, and you can find it chlorate. Calcium is not a transition metal, so I don't have to worry about parentheses. We're just going to name it as is, chlorate. Easy. But cobalt is considered to be a transition metal. So in this case, let's go ahead and crisscross backwards. So don't forget, when you're dealing with transition metals, you need to crisscross backwards. I'm going to come over here and I'm going to highlight that, and I'm going to just because again, that is probably the number one mistake that students do. They forget that if it's a transition metal, we need to crisscross backwards. Okay. That is a transition metal, so we need to crisscross backwards. That means that this is going to be cobalt. We're going to add our parentheses for our oxidation number, and that is a 2 that came over here. This is going to be a +2 charge, and Roman numeral 2, close parentheses, and then we're just going to name the other polyatomic as is, which is hydroxide. That's it. Radium. All right. So radium is going to be an Ra. It's a metal. And then they gave us hydroxide. Okay. But before I go any further, we're going to write the formula. What do we need to do with that when we're doing formulas? We need the oxidation number. So radium is in group 2, which is a +2 charge. Hydroxide, which is a polyatomic, is a -1 charge. Let's crisscross those. So radium is going to have a 1 behind it, so leave it alone. But this 2 is going to come over here. Hydroxide is going to be a OH, and this is a 2. Can I put a 2 over here? No, because that means that there's 2 hydrogens and there's only 1 oxygen. Hydrogen and oxygen is a 1-to-1 that come together. So I'm going to have to use parentheses, and then I can place the 2 behind it. Remember, if this over here was a 1, I would not have to use parentheses. Actually, if you did use parentheses with a number 1, that is incorrect. Any number other than 1 must use parentheses as a reminder. Let's keep going because we've got more practice over here using polyatomics. Magnesium, okay? We're going to go ahead. All of these are writing the formula. So what do I need to do when it comes to the formula? I need the oxidation number. So magnesium is a +2 because it's in group 2. Acetate is a -1. I'm going to go ahead and just write all of the charges on here, and then I can go back to naming. Sodium is a +1 charge. Peroxide is a -2 charge. Ammonium is a +1 charge. Phosphate is a -3 charge. And don't forget, ammonium and phosphate, that's 2 polyatomics. That could happen. Mercury, which is a, look at this, Roman numeral +2 charge. And acetate, which is a -1 charge. Silver, transition metal, +1 charge. Nitrate, which is going to be a -1 charge. So don't forget, we're going to crisscross. So crisscross. And magnesium is going to be a Mg. The 1 comes over. We leave it alone because it's invisible. But we have a number 2 that's going to come over to our polyatomic. Anytime there's any number over here that crosses to my polyatomic, any number other than 1, we must use parentheses. So let's go ahead and write our parentheses. And it's, what is acetate? Acetate is C2H3O2. Parentheses, this 2 comes behind it. Okay. Sodium. Sodium is Na. The 2 crosses over. Peroxide. This is a 1, so I do not use parentheses. If you do, that's incorrect. You're going to get it wrong. Okay, so no parentheses. Peroxide, which is O2. Okay, let's keep going. Next one, ammonium, which is a +1 charge. It crosses over here. What do? +1. I leave it alone with no parentheses. But ammonium is a polyatomic as well. And this 3 is going to cross over. So that means that ammonium is going to have parentheses. Let's go ahead and do that. NH4, close parentheses with the 3. And phosphate, which is PO4. Mercury, which is a transition metal. So let's go ahead and do that one. It is a 2, which is going to crisscross this way. Acetate is a 1. Acetate is a polyatomic. Any number other than 1 has to have a parentheses for polyatomics. So we're going to do mercury, which is Hg. All right, we have to use parentheses. And acetate is C2H3O2, close parentheses. And then let's put that 2 behind it. And then let's practice again. This is a 1 and a 1. Okay, we don't put anything for 1. They're invisible. So in that case, then we're going to do silver, which is Ag. And then no parentheses on the polyatomic, NO3. All right, so again, it's just practice over and over and over. But now the next type of naming is acids. So let's talk about acids, because acids are a little different. Okay, they're a little different. They have some rules to them. They're a little tricky. So let's look at it. Acids are compounds where hydrogen comes first. Hydrogen. One more time. If there's a hydrogen, it always comes first. And that's an indication that that's an acid. Okay. It doesn't indicate how strong the acid is. Okay. There's weak and strong acids. But the hydrogen indicates it's an acid. Right? And you should be careful with all acids because you're not sure. If you don't know if it's a strong or weak acid, then be cautious. Acids are compounds that produce hydrogen ions in a solution. That is what indicates what an acid is. And it's in water. So when you put an acid in water, the hydrogen breaks off and there's hydrogens all inside of that solution. Okay? So let's go ahead and let's go and look at the rules. So first thing is we are going to have acids. And when naming acids, they always start with hydrogen. Okay, that's how I know that this is an acid that I'm talking about. And then there's 2 types of acids. Okay, there's the first type over here. We call it binary. And a binary acid is going to be a hydrogen ion plus an element. Okay, for an example, it's going to be an H with something behind it. That's it. The other type is ternary. Ternary. I get tongue-tied. Ternary. Ternary. And what does that mean? It's going to be a hydrogen ion plus a polyatomic. Okay, so in this case, you're going to have a hydrogen, and then what's the word poly mean? More than one. So polyatomic is where you have 2, 3, whatever, 4 elements that are bonded together, and they always come together. So I'm just going to put a couple of dashes over here, and that's what it's going to look like. Okay, now let's go to our rules. When it's a binary, which is the easy one, you're just going to, when you write the actual name, you start off with hydro. Then you're going to add the root of the element, kind of like how we did before. So the root of the element. And then you're going to add an ick behind the root word. Then you have acid. So this is one word, and then acid is a second word. It's 2 names. Hydro, the root word, ick, acid. This is all one word. Okay? Ternary, well, there's a couple of rules here. It depends on the polyatomic. Okay? So whatever there's 2 types of polyatomics. If you go back to that polyatomic list, then you're going to see it's either going to end in an 8 or they're going to end in an ite. Okay? So the polyatomic has a name and then it ends in ATE, or it's going to be a polyatomic name and it will end in ITE. Okay? So if it ends in ATE, the polyatomic, then we're going to have the polyatomic name, and then we're going to change the ending to ick. And then we're going to name acid behind it. So again, it's only 2 words or 2 names, first name and the second name. If it's an ite, ITE, polyatomic, you're going to include the first part or the root part of that name. You're going to take away ITE, get rid of it, and you're going to include us, O-U-S, and then the name acid behind it. So again, it's another 2 names, okay? Making sure that we know that there is no hydro. All right? Now, what is our saying? Because there's a lot of sayings or a lot of things to remember, and I like to have some little sayings or things. So I'm going to come over here and highlight this just to kind of have this. And this is a very common thing, very common way to memorize it. Ick. I ate a poisonous bite. Ick. I ate a poisonous bite. Okay? IC goes with ATE. OUS goes with ITE. Okay? I don't know. Either you use this and you write it down and brain dump it onto your quiz and test. Okay? Eventually, it's stuck in your head because you do it so much and you just know. Okay? But for a while, I would go ahead and I would brain dump that, and I would know that ick goes with ATE. Us goes with ITE. Okay? Again, it's just practice over and over and over. So let's go ahead and practice naming acids. Okay? So let's practice this one. H3N. Okay, so in that case, this is going to be a binary. Look at this one, HNO. What is this one? Ternary. Okay, maybe that would help us out a little bit. HNO3. Ternary. HBR. Binary. Okay, so maybe that will help you if you need to do that for a while, so that way you know which one you're talking about. All right, but let's go with the binary. First thing is, you're going to start off with the word hydro. Then you're going to go to the root name of the element. And obviously, we're not talking about the hydrogen because they all have hydrogen. We're talking about that second one, which is going to be nitrogen. And the root word of nitrogen is nitric. So here is the ending, IC. We have hydro, which is the prefix, and nitric is the root. And then we put the word acid behind it. Hydronitric acid. And again, it gets tongue-tying. Okay, let's come to the next one. We have hydrogen and we have a polyatomic. So we need to go to our polyatomic chart so we can find that. And for a while, if I was you, I would probably come over here and maybe write down what this polyatomic name is on the polyatomic chart. This is nitrite. I-T-E. Nitrite. So N-I-T-R-I-T-E. I-T-E. What is it? I-T-E becomes an O-U-S. We do not use the word hydro. So we're going to go ahead and write out that root word of the polyatomic, change the I-T-E to O-U-S, and then we add acid. So it's going to be nitrous acid. O-U-S. Okay, let's keep going. NO3. Go to the polyatomic chart and let's write down what NO3 is. And that's going to be N-I-T-R-A-T-E. A-T-E. Nitrate. 8. 8 is going to turn to an ick. So let's go ahead and write that in. Nitric. I-C, because that's what it changes to. And then acid. Alrighty, let's keep going. H and Br. Okay, just an element, hydrogen and element. What do? We start off with hydro. What's the root of the Br, which is brome? Brome for bromine. So brome. And then we change the ending to IC, ick. And then we end up with the name acid. Hydrobromic acid. Let's keep going. Oh, there goes a polyatomic. So we do not use the hydro. No hydro for polyatomics. In this case, we're going to go find the polyatomic name. Okay. What is an end in? Go to the polyatomic chart. And when you look at it, it ends in an I-T-E. What does I-T-E become? O-U-S. So let's go and write that in. Phosphorus, O-U-S, acid. Okay, polyatomic. Go to the polyatomic chart. What is this ending in? It ends in A-T-E. What is A-T-E? Becomes an ick, I-C. So let's go ahead and let's write that root word part and change the last part to an IC. So acidic acid. Alrighty, now they have the actual names here and they want you to write the formula. So that's doable, that's easy. But don't forget, polyatomics, transition metals, and then a metal and non-metal, all of them are considered to be ionic bonding. And when it comes to ionic bonding, what did we learn in the first page of our notes over here? Crisscross. So I'm going to go ahead and I'm just going to write this note over here. crisscross. Just as a reminder. So if we're going to crisscross, then that means that we need the oxidation numbers, right? So you need the formula chart. But do you really need the periodic table? No, because hydrogen is in group 1. That's probably something that you already have memorized. So all of them are going to be a plus 1, right? Plus 1. They don't have hydrogen here, but I know it's a hydrogen starts with it because there's acid and a hydrogen is a plus 1. Plus 1, plus 1, plus 1. And again, if it starts off with hydro, it's binary. If it doesn't start off with hydro, but it has the acid behind it, it's ternary, which is going to be a polyatomic. Okay, so let's go ahead and let's finish. Hydrofluoric. Okay, let's go to fluorine on the periodic table because we're going to need the periodic table for this part, not the hydrogen. Fluorine is in group 17, right, or group 7, which is a -1 charge, right? Hydrobromic, we're going to need that one. So hydrobromine, bromine is in group 17, a -1 charge. Okay, let's go ahead and let's look at nitric acid. Nitric, okay, go to, this is IC. The name is already done, so we have to work our way backwards. IC is an ATE, nitrate. So now go to the polyatomic chart and find the nitrate with an ATE, not IC, because IC is going to be when we name the acid. So now nitrate, when you go to the nitrate, that is a -1 charge. Let's go to number 10. Sulfurous acid, OUS. Look at OUS over here at the top. What was that originally before we named it the acid name? It was an ITE. So sulfuric acid. So this was originally an ITE. This IC was an ATE. Okay, ITE, when we go over there, sulfurous, sulfurate, can't even speak right now, tongue-tied. -2. Nitrous, OUS. Look at this OUS. What was it before? This OUS was an ITE, nitrite. So go to nitrite, which is a -1 charge. Phosphoric IC was originally an ATE, phosphorate. Go find phosphorate, which is a -3 charge. Okay, so now that we've got all of our charges, do not forget when you're going from the name over to the formula, you need to crisscross it. But when you crisscross it, don't forget the ending was actually changed. And so you've got to come back over here to find out what was the original ending part of it. Alrighty, so now we're going to crisscross 1 and 1. Don't forget, what do we do when we crisscross with ionic bonding? We do reduced. Crisscross, crisscross, and those are pretty easy. +1, -1, we ignore it and we don't put anything. +1, -1. Oh, this is a 2 and this is a 1. This is a 3 and that's a 1. But other than that, we don't have to reduce because of 1 and a 2 and a 1 and a 3. So that's not hard. Let's go ahead and come back over here. So hydrofluoric acid, there is no numbers that are going to go behind it because it's a 1 and a 1. They're invisible. So I know they always start with an hydrogen. And this is fluorine. And I'm done. Nitric acid, which is a polyatomic, but it's an acid. So it starts with a hydrogen, an H. This is a polyatomic. So now I go to my polyatomics and find out what nitrate, ATE, was. And that's really an NO3. This is a one that comes down, so I do not use parentheses. Let's come over here. Hydrobromic. Hydro means that it's an acid, and it tells me acid. Bromine, which is going to be a BR. Both of those are ones that crisscross, and so I don't need to put anything there. They're invisible. Sulfurous, which is a ITE originally, go to your periodic chart and always write H first. Okay, so now that I wrote H, go find this polyatomic. It's really an SO3, but don't forget this H has a 2 behind it because it's crisscrossed over. So H2SO3, no parentheses, because this one crossed over and we do not use parentheses there. Okay, this is not nitrous, it's nitrite. Go to the periodic table, but it's an acid, so it always starts with an H first. So now let's go find that polyatomic. This is the 1 and a 1, so I do not need any parentheses at all. NO2. Phosphoric, which was really an 8. Go to the polyatomic chart, find out what the formula was for this, ATE. I do know that this is a hydrogen because it's an acid, and look at that. That's a 3 that crosses over to the hydrogen. So we're going to add a 3. This one, we do not use parentheses. It's going to be a PO4, and we're done. Again, it's going to take some practice, and I apologize for all of this weather and craziness that we had going on. Okay, so we will definitely get back on track. I hope if you watch this will help you out a little bit more, but I will definitely revise the calendar for us all so that way we can all get back on track. All right, now the last part here is just practice, and it's practicing all of them combined together. All right, because when you take the quiz and test, it's not going to be broken into covalent bonding, ionic bonding, transition bonding, polyatomic bonding, and acids. It's not going to be broken apart like that. It's going to be all mixed together. So this is some good practice, okay? Don't forget, if it's ionic bonding, whether it has a polyatomic, whether it's an acid, whether it's a transition metal, you need to have the oxidation number and crisscross them. And if need be, then they're going to have to reduce. If it's a covalent bonding, we do not reduce, and those it either is going to have a prefix, which indicates the number of atoms for that element, and so you're going to have to write that little number down there below it. Okay, so let's go ahead and let's practice this. So hopefully we can get through this and understand this a little bit better. All right, and hopefully it's a little bit easier. But we're going to have to practice. That's what it's going to take is practice. So if I see a prefix, then that means it is a covalent bonding and it needs a subscript. So prefix, subscripts. There is no reduce. Okay? Acids, don't forget that's an